So carrying on from the first WPF tutorial, turns out a lot of you really like the WPF side of things, so we're going to try and do quite a few more videos on WPF before we do any others now. This video we're going to go through TreeViews, which are a collection. So previously we've done stack panels, grids, and single items. There's another type of item in WPF, and it's anything that's a collection, anything that's like bound to a list or an unknown length of items. So for example, when I was trying to think of what to do, here's a perfect example. So folders. So if you go into your documents and then into another folder, this list is an unknown size. So we're going to create sort of this side of the folder explorer for now. That's a good example to get started with some basics of a collection view. And then we're going to use value converters, which you'll come to use a lot more in WPF. It's going to be a really basic way of using them again, and that's going to be to select whether the item's a drive or a folder or a file and show a different picture. And that's really what we're going to do for this next application. Just want to talk a little bit about the upcoming things. So we can't go much further into WPF without hitting on like view models. Just because the way that WPF is naturally designed to work is with view models, and it's a good thing anyway. It's something you should get into. It's just that I feel we haven't really covered enough to move into view models. That they can be quite complicated, and understanding more so the reason why you're doing it is going to be the difficult thing. So we're going to have to cover them in the next video anyway. But you're going to get to the stage where you might not fully understand why we're using view models initially, like the benefit of them, because it'll look like a lot more work than just creating and setting text box values and things like that from the initial stages of where we are. But as you develop a full application in future videos, that the purpose and the benefit of view models will come about afterwards. So just bear that in mind when we touch on view models. And then also, with a lot of what we're doing, it's going to be a lot of reusable code, a lot of logic, and a lot of helper classes that we want to start using going forward. We want to create this nice library. So I'm creating something called the DNA framework, which is going to be a completely cross-platform code base that will work on Mac, Linux, Windows, Android, iPhone, the whole works of all modern devices. And we'll start using this in the next videos and creating it on the videos. So again, you'll see the benefit in the next videos. And then to try and get you excited, the ultimate goal now of these videos is we're going to recreate a real application that's actually live in the store right now on the Windows, Android, and iOS stores. And I'll take a quick look. So one of the companies I run is called Facetto, and this is the app that's currently on the store. It's sort of a combination of friends, contacts, files, and chat. So you can, use it like that. The problem with it is this was made originally many years ago, and Facetto was a cloud storage mechanism. Then it turned into more robust file storage. Then we added friends, then contacts, then an auto uploader, then a chat, then a help system. It got really cumbersome, and the original back-end database and servers just weren't designed for being used the way they are now. So this has got quite slow. So I'm going to remake this entire application, and we're going to do it on these videos. We're going to do the chat application. So I've got a new product that's coming out. It's Link, which is going to take over the files. So we're going to recreate this chat application in these videos. So not this very first one, but after this video, we're going to basically head towards making this full-blown application, including the website, the database, the back-end, the Android and iOS apps, the complete works. We're going to build this entire app so it's nice and fast. So that's what's to come. So let's get straight back into the WPF. So quick recap, we're going to make this file explorer thing here. So new project, WPF app. We're calling it TreeViews and value converters, so it's in this folder. So we'll just call it WPF TreeView for now. And then here's the basic window. So the first thing we want in here is a tree view. We're in a grid. Let's just quickly change this to a stack panel, just so I can show you what it's going to look like after when we come to do something in a short while. So just make a tree view, give it a name, call it folder view, and then that's really all there is to make the tree view, and we can use that as is. But what you'll get when you add items to this is just plain text, just like a normal string written on the screen for each item, whereas we want to display an icon and the text. So there's many ways in WPF to accomplish the same task, and that still goes for each individual item in the tree view. There's also many ways to add the items to the tree view, so this isn't the only way to do it, but this is one that we'll show you. So again, aimed at just the quickness for now. So if you do TreeView.resources, that's going to add, we're going to add a style that's just local to this control itself, and that style is going to override the items we add to it. So make a style. Target type is going to restrict what this is going to run on, you know, what the style is going to apply to, and then you'll see we get some kind of really strange syntax here. So these curly brackets basically drop down to, instead of being in this XAML normal text where you're just typing things, it drops back into more of code behind sort of thing. It analyzes these code files. You do the special tag X, which is here, and that's going to tell it to be part of the XAML styles, and then there's a special type inside of the X, which you've got type, static, reference, and null. So don't worry too much about it, but that's basically what you do when you want to specify a type. And then this is an actual type. So tree view item, if you went into like code behind and typed tree view item, you can see it's a class. So it's finding this tree view item, which is what we're going to add to each. The tree view is going to contain a list of tree view items. So this little style here is effectively saying, for this control only, because the resources are inside the control, and only when the item is a type of tree view item, because inside the tree view you can actually add multiple different types of item. You could have tree view items, you could have combo boxes, you could have buttons, you could have a completely custom view. So this is saying only if it's a tree view item, which we don't really need in ours because we're only adding tree view items, but it's good practice to make sure that what you're styling is the type of thing you're expecting to style. And then before we actually make this style, let's show you what we want it to look like. So go to the stack panel, and we just want to make, again we want, where are we? Let's hide that a sec. We want an icon and text. So from the last video you should remember you break down the view, and it's effectively a stack panel horizontal, because we've got, you know, a single item that's just the size we want it to be, and then another item. So let's just make it here so you can visibly see what's going on. So we've got a stack panel, orientation, horizontal, and I think that's it for that. And then inside that, we also need to add the images now. So I've gone ahead and just made a few images. So right click on the project, add folder, call it images, right click, add existing items, and I've just dumped them here for now. So let's include these, and we've got a drive, which is like a, you know, an actual drive. You've got a file, you've got a folder open and a folder closed, which I only use the folder closed for now. I didn't bother going much further. So we've got some images to use here. So the first thing we'd want for an item is going to be an image. We want the source, and again this is just so you can visibly see what's going to happen. It's not going to be the actual exact code we use, but there's an image. You can see it's gone huge. So we just want to restrict the size. So I want, like, say width 20. That's fine. If we put multiple ones of these, and we just remove that a second, just so you can try and get an idea of what I'm showing you. See, there's no gap between these two, so when we come to stack tree view items down, you're going to have this non-existent gap. So let's just add a margin as well. We want the margin to be all around. We'll do, say, like 3. Just gives it a little bit of a gap. So that's all we need for the image. This path will have to change based on the type of file, but we'll do that after. And then we just want the text. We'll use a text block, and then we want the text to be some folder. Remember, this is just visually as an example. Now you can see this is up, it's aligned vertically to the top. We want this to be nice and central based on the image. So that's really easy. Just do vertical alignment center, and that goes there. And that's really it, as simple as that. This little stack panel can quite easily represent an item in here. So that's what we want to then use per item, per tree view item, so for every one we add. So let's just shrink this down slightly. And then we're just going to cut the stack panel. This can go back to a grid. And then inside this style now, so that for every style of a tree view item, we need to edit the, I think it's the data template, is it? No, set it up property first. So in a style, you can set something. So the thing we want to set is the header template, I think, on a tree view item. So yeah, so a tree view item for the most part just has a header and some content. We're just going to override the header, and then we're just going to set the header. The header is basically, as a default tree view item, is just a string, just a plain piece of text. So we're going to override that template, and then instead of the value being in an attribute, because it's going to be an actual full style, you do setter.value. And now inside here, we're finally at the point where we're going to set the actual content, the direct content that's going to be inside each header template. That needs to be the data template, because that's the type of this value. The header template is expecting a data template, and again, this is all fairly standard when you're overriding templates. So this whole thing, all the way here, is basically saying whatever content ends up in here, this little bit here, we don't care about all this really. What ends up here is going to override this item's content, if you will, the actual WPF that's going to appear as a content. So although this looks like a lot of steps going down, this is fairly standard. This is hard coded. You've got the tree view item, and then you've got a header template. And if we go to the code behind again, you did var t equal new tree view item, and you did t, and you can see you've got a header template, so you can see all the code, and you can see it's expecting a data template. So that's how you can sort of see what's going on. And you can even click on the header and see gets or sets the item that labels the control. So it's basically like a label by default. So all we're doing there is getting a tree view item, if the tree view item's in the list, getting the header template, and then replacing it. And just paste your stack panel into this part. Whoops, we didn't close that off. Oh, all my cut and paste has gone a bit strange there. There we go. So that's now inside. So if we run this now, which we can do and we will, just to show you the list starting, we need to, when the program opens, we're going to pull in the logical drives to start with. So in the window, we did this in the last video, just do loaded, press enter, then press tab to create the new window loaded. And then in the code behind here, we're going to get, we just do it directly, so let's just clean up this class a little bit first. Get rid of that. This is going to be unloaded. And the application first opens. So when we load, and again, bear in mind this program now is really, this is not what you'd take commercial. This is just a quick one of, proving how to do something. So you wouldn't normally just get the window to load and directly add values and things. This is just to get you familiar with a tree view. And then after this video, and we move on to the main chat application, everything's going to start being exactly as it will be in a final application. So this is a little bit of a quick way of doing things, just to again get you familiar with the concepts of what we're trying to do. So when it opens, so we just press F5 first. Let's make sure this actually opens and runs. So there you go, you're fine. You've got a plain window. You can see this little grey border all the way around. Just about see it between the blue. It's just inside the blue, and you can see it along there. That's the actual tree view itself. That's got no items in. So we're just going to do directory dot get logical drives, which is a helper in the .NET framework. It retrieves the names of the logical drives on this computer. For example, drive letter : /. So we'll get the logical drives, and then for each of those, it's going to let me do that. What have we got? Oh, we've got an array. Okay, let's just drop back to a for each then for now. So for each drive in the logical drives, we want to create a new TreeView item. And then for that item, we want to add it to our folder view, the tree view. So items.add. And then we can actually run that, and what we should see straight away is just a list of items with, and there we go, we can already see our default stack panel for each item. So we've got 3 logical drives, which we know we have, and we've already got the icon appearing for a drive and the text, which is quite nice. So we just stop that. So now we need to fill it out with some information. So we overwrote the header template, so we want to set the item's header. So item.header equals, and then we want to just set it to the drive, and that's going to give us, or is not going to give us, oh yeah, that would give us the value. So what we've got to do now is replace this hard-coded text. So we're going to do a binding now. So in WPF, instead of it being like hard text, this is an item, so this is a TreeView item, and it's this item here. By default, the context, the thing that you bind to, in terms of, you know, accessing data from in here, it's going to be the item itself. So we're inside a header template, so we just want to bind to the actual header itself, which we've set here. And because it's a string, if we bind the text directly to that, it's literally going to convert it straight back to a string. So in order to do a binding, you do the curly brackets and you type binding. And this is the simplest possible type of binding. So we're not specifying anything. We're literally just saying it's a binding. And what that does, it defaults the binding to the location of the data context of the item, which is the header. And the header itself is just string. So effectively, you're just binding it directly to the header itself. So again, we'll do more complicated bindings afterwards. This is one of the key things to WPF, is you'll spend almost all of your time in WPF learning bindings, value converters, and the structure of like templates and things. They're really the 3 key things, and binding is one of the massive parts of WPF. But luckily this is a simple introduction, just so you can understand that when you say binding, because we're a header template, so this template, its value, its data comes from the header itself of the item, and because we've set the header here to this value, the text now in that block should show the drive letter, which it now does. So you can see that's got the drive letter. We also need, so if you imagine you start with a drive letter, and we're going to expand down, and we're going to go from, say, the C drive, and then we're going to go into, say, Freescale, and then we're going to go in KDS. So when you get to, say, this point, as we're clicking these items, we need to know the full path. We need to know to get the folders inside the full path. It's no good just having the name, and right now the header is just going to be set to the name as we go. So we also need to set the full path as well as the name. Again, a more appropriate way to have done this was to probably create not a TreeView item, but to create a new class that contains the information we need and bind into that. But again, for quickness, we can actually do this just with a TreeView item, because we have an extra thing called a tag. And this tag is literally just an object where we can store any information we like. So the tag in this instance is still the drive, because that's still the full path. But when we come to do the other items, you'll see that will become the full path, and the header will just become the name of the folder or the file. And then you'll also see, if we run this, we don't have any expand icon here to actually try and get into the drives. And that's because by default the tree view knows there's no items inside, so it's not even giving us an option to show the expand. A quick trick to get that, and first let's go back and comment some of this. Every drive on the machine, create a new item for it, set the header and path, add it to the main tree view. So here, if we just do the item itself, which is the current, say, C drive, it in itself has also got inner items, because the tree view just keeps going down and down. And if we just add an item, and literally just add nothing, just add null, add a dummy item, and then we run this, you'll see we get the expand icon now. And then we've got a dummy null item. And the reason this is then shown an icon and no text is because, as we said, every single item we have will override and get this stack panel. The image is right now just set as a drive, and the text is bound to the header, which in a null item is null, so you just gain a nothing appearing. But that isn't the purpose of this. We added the null item just so we can get the expand. Then when we expand, we're going to listen out for that event, and instead of just showing that, we're going to remove that item. We're going to actually find all the files and folders in this drive, and then we're going to add them to the list. So let's just do that next. So that's the logical drives done. Then we want to go below here, and we want to first check out on the tree view itself. We need to listen out for when the items are expanded. So we do that with, well, we can do it if we were data binding, we could do it a different way, but because we've hard coded the item here, set drive, add dummy item, and we're just going to explicitly add to the event. So listen out for item being expanded, and I think it's just item.expanded, and we'll call this folder expanded. So that's going to listen out whenever the folder tries to expand, which is what we wanted. And then in this, we first want to get the item itself, so we want to get this tree view item. The sender of the folder expanded is the tree view item, so that's going to be the item. So of type tree view item, and it's the sender. So this will get this item. Now we want to check, because you could expand and collapse, and if once you've done it more than once, this might not contain dummy data, it might contain the real data, in which case you could either refresh again anyway, or you could just ignore. So we're going to ignore for now. We're only going to replace it once when it's expanded, just for quickness, I guess, so it doesn't wipe out all the inner tree views as we go. So if the item only contains the dummy data, and to find that, we check if the items count as 1, because we've only added one item in this instance, and the item's first item is null. That's how we're going to detect that we've got that dummy item in there. So in fact we want to reverse this logic. So if the item's count isn't equal to 1, or the item isn't equal to null, and again you use reverse logic as much as possible so that you don't end up with ifs inside of ifs inside of ifs, and then your code's halfway over the screen. So basically if the items isn't equal to 1, or if it is equal to 1 and it's not null, so just the opposite logic, then we ignore it. So this, if it returns here, it's because the dummy data isn't in, we've already done something. Otherwise we get to here. So if we get to here, the first thing we want to do is remove the dummy data, so just clear the items off. So clear dummy data, and then we want to get the folder name. So by default it's going to be this tag, so folder name equals item.tag, and we know it's a string because we're setting it, so we just cast that to a string. And now we want to get every folder that's inside of this folder. In fact, this is not the folder name, sorry. The tag is going to be the full path. So get the header and the full path. And again, you'll see this being set in a min when we do a recursive loop. So that should be full path is the tag. Now we want to find every folder first, so we want to add folders and then files. So for every var directory path in, and then we'll use the helper get directories. Now the thing you've got to be careful with here, past the full path, is that this call to get directories can throw, if you see the exceptions, unauthorized exception, path too long, in, out, etc. There's a lot of ways this can fail. So we don't want it to crash the application if we can't get the folder. We just want to, for now, we just want to ignore it. So this is really bad practice in most places. You almost never ever want to just do a try catch like this, because that basically wraps any possible problem here, and any problem that happens just gets ignored. So let's at least try to mitigate this slightly, and let's just do var directories equals, and we'll just do a new list of strings, and then in the try catch only we'll do directories equals, and then if we have any directories, then we add it to the main list above. So all we've done there is inside a try catch only done this single call that we want to basically catch and ignore. So if the user doesn't have permission to the Windows system folder, then this would crash, and in that case we just basically catch it here, do nothing and carry on. So all it means is that folder won't appear in the list. But like I say, this try catch thing that so many developers do as well is a really bad practice. There's so few cases where you just want to try and catch and basically ignore every possible issue that could happen. So instead of doing a try catch and then writing the whole code inside this and adding it to the list just because we were expecting this to possibly fail, you could end up failing inside the logic of adding it to the tree view and then something else is failing. And what that would result in is just nothing appearing in your application and no errors to the user. They just presume everything's okay when it's not. So rarely do this, but in this instance we want to create a blank list try and get directories from the folder, ignoring any issues doing so. So then once we've done that and we've possibly got the directories, we want to then iterate over all the directories, and we're going to do directory path, and then for each directory we now want to add this directory to this item. So we want to add all the directories to that item itself. So we want to create, we'll call it a sub item as new tree view item. And in fact we can clean this up slightly. So when you create a new tree view item and then you go ahead and set values like this, it doesn't quite look as obvious that you're setting the item. You have to look here that you're doing things to it. So when you're setting properties directly on the item, you can just do it, get rid of the semicolon, do your curly brackets, and then just move the values inside, and you change the semicolons to just commas, and get rid of the item because you're in the item. And that's another way of setting the properties of any class at the same. So you create it, that'll call the constructor, and then after the constructor's run we're then setting the values, and that just makes it look a bit more obvious that you're setting the header of the item and the tag of the item. And then things like this, items.add, you can do afterwards, because it's I don't think things like adding to lists and things are appropriate inside this constructor. That's more of doing something afterwards. But you could technically put all this inside. But I do that when you're setting properties usually to values. It just looks cleaner. So we'll do that here as well. So for the sub item, create the sub item, and then we want to set the header, and then we're going to have now a directory path. So this is going to be say the C drive, Freescale, KDS. So this directory path, say we were at the point of we click the Freescale item and then we found the KDS folder. Now this directory path is going to be the full path. It's going to be this, and then as you go into another folder, it's then going to be this. So your directory path is going to be a full item. You want to make sure you get we want this bit, the last bit, the name, to show up in the list, the last item. So you can do path dot get directory name from the directory path, and that will get the directory name. What's he complaining about? We've got Windows has added Visual Studio has added all these unused namespaces we don't need, so that shouldn't complain now. Really, we're still using Windows Shapes path. What are we using Windows Shapes for? Nothing. Right, there we go. So that was complaining because you've got a system.inout.path and you've got a windows.shapes.path, but I just removed the using up here that was in there for some reason for the Windows Shapes, which we don't need. If you did need it, then you could just type system.io.path to get directly to it. So that's going to get the directory name from the directory path and set it to the header. And then, as we mentioned, now the tag, which is the thing we then look for every time you expand something, we get the tag here. We need that to be the full path in order for this get directories to work. So every time we're going into a folder, we need to know the full path to get the folders inside of that. So the header is just the name of the folder, like in this case doc, and then the tag is going to be the entire path. So the tag is just going to equal the directory path itself. So create directory item, set header as folder name, and tag as full path. And then we want to then do the same thing with this. We need the items to have a single dummy item. So add dummy item so we can expand folder. And that's that. And then we also want to listen out for the expanding events again. So subitem.expanded plus equals, and then it's going to be this function again. So it's going to be, what did we call it? Folder expanded. So that even when the sub items are called, it comes back into this recursive function, if you will, the same function that handles every item. So that'll handle the expanding out. And then we need to add this item now to the parent, which is here. So whatever item expanded as, we need to now add the sub item to. So item.items.add sub item. So add this folder or add this item to the parent. And that's it. With that alone now, when we run this and we click expand, so let's put a breakpoint and we'll go through it. Press F5 and get rid of this modules window now. So this is run, you've got the expand, we're going to click expand and we should hit this folder expanded, which we do. We're going to get the sender, which you'll see is the TreeView item with the header C drive with the single dummy item. So we went down to items. Come on, where's items? There we go. And you expand the items, there's a single item, and that's the dummy null item we've got. So if the items count isn't equal to 1, which it is, and the first item isn't equal to null, which it is, so we carry on. It's going to clear the items out, it's going to remove that dummy item. It's going to look for the tag on that item, which is the C drive, because in the main logical drives the tag is the same thing, it's just the master drive. Then we're going to create the blank directories. We're going to ask for all the folders inside of the C drive, just the first level, not consecutively, recursively down. That succeeds. We get 20 folders. So this is all the folders in my C drive. So that's cool. We add them to the range. And then for each one of those directories, we're going to then create a sub-item where, in this case, the first one is recycle bin. We're going to get the directory name of the recycle bin, which should just be recycle bin. It should remove the C drive. And the tag should stay the same. So the sub-item now has, let's go and check the header. So the header is the C drive, which is wrong in that case. So it's got the, doesn't basically handle the directory switch, so we'll write a helper function to fix that in a moment. And then the tag is obviously the full path, which we know. And it's going to add the item. It's going to listen out for it to be expanded again. It's going to add it to the main list. So let's run that, and you're going to now see that this is effectively going to just show a load of C drives. But you can see it's shown for each item. So let's go ahead and fix this directory name. So we'll make a little helper for this then, because path.getDirectory hasn't really worked. So let's call this get file folder name, and this is going to be a helper out here. We'll make it public static so that anyone can use it for now. Get file folder name and the path, and the point of this is going to be find the file or folder name from a full path. The full path. So what we want is, if we have C drive colon something colon a folder, and we also have, say, a file.png, what we're looking for this function to return each time is this last part. So the very last part of the backslash, if you will. So the first thing we want to do is make sure the path has something. So if string.is null or empty path, then just return an empty string, because there's nothing we can do. So if we have no path, return empty. Then we also want to, in some cases, so again, thinking more cross-platform wise, if you're running on Linux or Mac, these might be forward slashes. Even if you're running on the web or your data comes from somewhere else, or for any reason, sometimes you'll find that backslashes and forward slashes very commonly get mixed up and cross-used. So we want this function to be able to handle that. So we'll call this normalized path. That's going to equal path, and then we're going to replace anything in the path. Well, in this case, we're going to replace any forward slash in the path. We're going to basically turn it all into backslashes. And you can't do a single backslash because that's a special character. So you put 2, and the 2 backslash just means 1, because that's the special character to escape things like putting tabs in and things like that, and return lines and new lines. So when you do a double backslash, that's a single character. And the fact that you've got a single quote here instead of a double quote, like you usually do, means that this is a character, a single character, not a double. So you can't put more than 1 character in these single quotes, because a single quote converts to a character. So we're just going to replace every forward slash with a backslash. So make all slashes backslashes. So now we know we're working with only backslashes regardless. And then you want to get the last index in terms of what we're talking about here. In the index is the string. So there's the string. It's say 20 characters long or something. Index 0 is here, 1 is here, 2 is here, 3 is here. We covered this in one of the very first C# videos. So the index is the position in the string. We want the last index, so the last position of the backslash. So basically we want to find the last backslash in the string, the one furthest to the right. Everything after that's going to be a folder or a file name. So the last index is the normalized path dot, and then there's a helper function, last index of, and we just want to do the backslash. So find the last backslash in the path. Oops, last index of anyone, last index of backslash. And then we want to make sure we've actually got a backslash, because one of these might be say just a file, and there's no backslash. We don't want to, this would then return -1. So if you don't find anything, it doesn't state there, but you just, when you try it, you'll find out that if it doesn't find an index of a backslash, so if it doesn't find it in here, this is going to be -1. So we want to check for that. That if we basically don't know, if we can't find a folder, we're just going to presume that the whole string itself is the file or the folder. So if we don't find a backslash, return the path itself. So if last index is less than or equal to 0 even, because 0 would be the full path anyway, then just return the path itself. Otherwise, we've now got an index. We now know, say, this position because it's found it for us. So now we just need to return the string after that backslash. So that's a case of return. We can return normalized. No, we'll return the path now because we want to return the original structure, not the normalized path. We don't want to change the input they give us. So if they input / here, we correct it to like a backslash just so we can find the backslash. But we want to return. Well, that's a bad example there. Actually, it makes no difference because you're not returning anything with a backslash or /. So you can return the path or the normalized path, makes no difference. You want the substring of the path, and then you want to start it at the last index, which is the position of the last backslash, which is here. Then you want to jump 1 forward, so you don't include the backslash. So it's everything after that. So it's the last index plus 1, and that's it. So return the name after the last backslash, and then we can delete that little comment there. So this should take like the C drive and the whole thing and find just the folder name for us. So we've replaced that with the helper. Let's press F5 and see if that's done the job. Don't need to step over it anymore, we'll just look. And there you go, you can see we've now got the folder names. So let's fix these icons next. Well, no, I'll tell you what, because that'll be more complicated. Let's add the files now as well. So where have I got some files? D drive, link cache, cache, thumbnails, large. So you can see there's no, it's not showing anything in here because we're not returning files, just folders at the minute. So collapse that. So in the unloaded, we aren't in the unloaded, this is now, move this out of this region, folder expanded. So in this folder expanded, we get the item, we do all that, we find the directories and we add the directory. So this whole code here is almost copy and pasteable. So let's just put a region because this is getting quite large. Get directories. And the region, we'll start a new region, get files. In fact, let's call it get folders. So we can collapse the get folders, get the files, and this can be region initialize or initial checks. So you can also use regions as you see inside of functions. When the functions get quite large, you can tidy them up with regions as well, and it just makes it easier to navigate a function. You could also expand this, and better practice I guess would be to make these functions themselves to get files and folders, but again, keeping it simple for now. So we just copy and pasted the directories, change it to a list of files, try to get the files from the folder. So dirs we'll just call, well, we've got files there, we'll just call it fs for files. And then the directory, I think you do get files, yep. And then we'll add it to the files list instead. So all the same logic, so we'll try and get the files now instead of the folders. And then for the files, we want to control RR and we'll rename this variable so that it renames these two for us as well. Let's call this file path. So for each file, get file item, sub item, set the header as file name. Now we've already made this helper function to get file folder name. That'll effectively just get the last part of the path. So that'll still work for a file or a folder. That's why we called it get file folder name. You know, a file and a folder are still can't have backslashes in, so if it's, you know, after the last backslash, you know it's the file or the folder name. So this exact code will still work. So set the header as the file name, set the tag as the full name, then add the item, add the dummy item so we can expand we don't need, because this is a file. You can't expand a file any further, that is what it is, so let's remove that. Listen out for it expanding. Actually, don't listen out for it expanding either, obviously, because we can't expand it. And then just add the item. So the files is a little bit easier. You get the files, you create the item, you set the header and the tag, and you add it. That's it. So press F5, and we should now have the whole thing. So D drive, thumbnails, large. I think we've got thumbnails, and these are pictures. So we want to just replace these icons now with a few of the pre-made ones. So I've made a drive, I've made a file, I've made a folder. We'll use the folder closed. So if we go back into the XAML now, you'll see the source of the image is just the drive directly. Now there's a little thing here where you're setting the source and you're just passing in a string. Now you might think you could just pass in a string and you can change this to images drive or images file or images folder closed. You can't do that directly, because by default in XAML, if you set the source here as a string, XAML actually converts this to a different thing. It converts it to like a bitmap image. So it takes it from a string and makes a bitmap image for us. So now we're going to replace this and set it directly. We can't just set a string. We're going to have to make a bitmap image ourselves, which is not overly complicated. So this is now going to take us into the realms of value converters. So in WPF, you want to keep the binding simple. You want to bind to something and it be the value. You don't want to have to start, say, binding to a string and then trying to convert it to an image here. You want to just set it to that string and then just have a converter that takes any string and converts it to an image. And that's the point of a value converter. Or, like, say you bind this stack panel to a property of binding here. And you want this panel to be invisible when the string is null. So then you could bind to, you could bind the visibility property. You could do binding, and you don't need to set the path because it's the actual thing. And you can then just set a converter. And you could set the converter to be something that is called, say, string to visibility, because the visibility is an enumerator, I believe, of hidden or visible. So you could then convert a string to a visibility property, and that's be a simple use. Again, we'll cover these a lot more in the next videos, so don't expect to fully get this, but this is a nice intro so you can see what happens before we delve into the harder stuff. So before we try and bind it, let's first make the value converter so that you can see what it looks like. I'm just gonna commented this. When a folder is expanded, find the subfolders files. That's that function done. That's the unloaded done. This is a region, just general helpers for now. So that's nice and tidy. So let's just make, we'll just put it in, we'll make a new class. Add class, and we'll call this header to image converter. Now a value converter needs to be static. It's because there's only one instance of it. Actually, no, that's not true. It doesn't need to be static because you can create instances. But the way I'm going to use it again for quickness is I'm going to make a static version of it so we can find it nice and easily. So you make a class, you call it whatever you want. Convention usually states that you end it with the word converter. And then it's an I-value converter. Control dot to include the namespace that you need. Let's just remove all these others that we don't need. And then you can see we need to override some properties. So control dot enter, and that will give us the values. So a value converter has two things. You can convert to something, So in this case, you can convert from the string to the image that we want, so the header string to the image, and then you can also try and convert back if you like. You can try and take an image and convert it back to the original string. Now in most cases, most value converters only go one way, and that's the same here. We're not going to support converting an image back to a string. We just don't need to anyway, so we just need to focus on this function. So I'll just say converts a full path to a specific image type of a drive, folder or file. So that's the point of this, is to take the full path and then figure out whether it's a drive, a folder or a file. So we first need to get the value. So when we bind this source here, we're going to actually pass in a binding of the full path. So let's start with the binding at least. We won't do it fully, but let's do the binding there, and then we want what do we want? Need to get the full path, don't we? In fact, the binding's going to be the the binding's going to be the header. So we need to find. Let's just do the binding. So by default, this binding is going to be the header of the TreeView item. Well, we don't want the header. We need the tag. And if you look at the code when we created them, get files, get folders. So let's see here, a folder. We create a TreeView item. We set the header to just the name of the folder and the tag here. Well, we've got the header right now. We're inside the header, so we can't get the tag because that's part of the parent item, the TreeView item, and we've only got the header. So in this binding right now with a header, we need to step up. We can't like just find anything. The binding will only work inwards. So we need to do a special kind of binding, which will say we need to start by stepping up the tree. We need to get back to, we want the TreeView item. We want to bind to that so we can access the TreeView item. So for the binding to do that, you need to set a relative source. The relative source is equal to, and then more curly brackets, and it's relative source again, strangely, but this is to define the relative source. We want the mode to be find ancestor. We might even be able to use templated parent, but let's use find ancestor. Let's basically step up the tree. So we want the ancestor, and the ancestor type wants to be again the X type. Oh, hang on, I haven't done the curly brackets. There's a lot of curly brackets when you do binding. The type of TreeView item. Let's try and break this down to be a bit more visible here. So we've got an image, we've got a width, we've got a margin. Set the source here, and then the source has got, oh, it looks a bit wrong. Just trying to make this break down on more lines so it's easier to see. So sort of like that, I guess. So you've got the source, which is the binding. In fact, we should put that on the line below. There we go. So you've got the binding. Inside the binding, you've got a relative source. And inside the relative source, I'm really struggling to try and make this look correct. That'll do. So you've got the binding of the image. That binding wants to be of a relative source. The relative source is find ancestor, and you want to find the TreeView. So again, this looks really messy, and like I say, it is for the most part. It's something you have to get used to in WPF, is this whole defining code in lots of curly brackets and equals and X types. It's not a very pleasant way of doing it, but once you get used to it, you just get used to doing it, and it's, for the most part, there's so many ways of doing the bindings, and then once you know them, you just get used to them. But again, just thinking on what this does, you're setting the source of the image, so you're trying to find an image specifically. You're trying to bind to something, which right now is the header. And instead, we're going to say we want the source of the binding, instead of to be the header, you want it to be relative to this item. You want to find an ancestor, which means step up, and you want to step up until you find a TreeView item. So what this binding here is going to do is turn the binding of the source into binding to the TreeView item directly. And then from that TreeView item, now we've got the relative source there. So let's just put that back on one line. Now you can see that. So the relative source has been found. There. Now, let's do that one. Nope. There we go. So the relative source we've got. Now we want the path, which is effectively saying TreeView item dot, and now what do you want to get? And it's the tag. So now the path can be anything that's, you see there, property path. So it's anything inside the TreeView item that's a property. And we want to get the tag. So now this is going to get the TreeView item, and then it's going to find the tag. So this source to the image is now going to be a string, and it's going to be the tag, which is the full path, because we set the full path here. So we're now going to get the directory path inside this binding. And again, that'll now set this image as a string. If we just run this, let's just comment this out a second, because I'm 99% sure this won't work like this. You can't just bind a string. So there you go. You can see you've got nothing for the items, but it shows that this binding is in operation now. It's trying to get something, and it's getting the tag. So now we need to convert the string, and in fact you can prove that as well. If you need to see what's going on, you could cut this out and paste it into the text. So instead of seeing the image, you can then have a look at what the text box says, and you can see now this is what we're binding the image to. You can see that each one is the full path, which is what we want. So that's where you can see the full path. So you know you're binding to the full path. So now we need to convert this string to the bitmap image that we were saying. So we've got the whole path, and now as well as the path you can specify a converter. And now the converter needs to find, again there's many ways you can find a converter. You can do a resources and then do it by key, or we're just going to make a static instance here so that we can just find it. So we need to get public static header to image converter, call it instance, and this is going to be a new instance of the converter. So we're just going to create an instance of this converter, and it's static, so that there's a single instance, we can access it directly. Let's just return new object for now, just so this can compile. Let's just build that. In fact, that'll moan because we didn't finish the XAML. So now the converter we can set, again, curly brackets as always, x colon, and then you can do static, and you should be able to do, we need to get into the namespace of our header to converter. So the namespace it's in is here, WPF TreeView. We've set up the namespace here as local, this special name. So in the static we can specify local colon, and now that's going to jump to our application. Doesn't look like it's smart enough to find it, so let's just make sure that when you're doing this and you're in a converter, this is trying to find the converter. So we can add an attribute here called value conversion, so it knows it's a value converter. We can even go as far as to do type of source is going to be a string, and the target type is going to be type of bitmap image. That's the one. And now that should find this header to image converter. Might need to compile first, but let's see. Yeah, so let's just remove the converter a moment and let's see if we can compile. And this should make it so that just delete this image a second. It should make it so we can find it using this. Nah, it's not going to play ball at the moment. But usually when you flag it with like a value conversion, this should find this class So we can do that dot instance because we know that's where it is. So we've explicitly said it's in the local namespace, which is this one. It's called this class, and it's the class dot instance because it's static. So it's the same as doing it in code behind. It's the same as going WPF TreeView dot header image converter dot instance. So we're effectively setting it to this. So the converter's being set that way. Again, I know this is a confusing way of doing things, but this just is WPF. There's something you just stick at and get used to, and just bear in mind that, again, most of your time will be spent trying to figure out why a path isn't working, or a binding isn't working, or a converter isn't working, because all of these things that are brand new to most C# developers, they don't tend to do this type of really confusing XAML. But we'll take it slowly, and in the next videos we'll delve into a lot more depth on bindings, because that's a big part of it. So we've set the path, which we've tested by putting this source as the text block. We know that's now the full path to the file or the folder that we're looking at. And then we're now going to pass the data into this converter, which we've created here, that we can then now return a bitmap image. So if we just put a breakpoint here as the first step, and let's check that we're actually getting passed in the values and that for each item. So if we press F5, you can see now we're hitting the converter. The value you can see is a string of C. The next one is D. The next one is E. And that's it. So the converter's working. It's been told the information. So we expand. We should now get the other full paths. Yeah, so C recycle, C config. So we're getting the full paths of each file. And we're now trying to set the source of that image. So instead of converting right now, let's just set an image back up. So you want to get the path first, which we've just seen is the value. So that's the full path. We want to check if the path is null, because we can't do much if the path is null. So path. So just return nothing. So we won't have an image of the path as null because we can't tell what it is. And then we want to get the, well, right now let's try and just return a bitmap image. So return new bitmap image. Ooh. And this is expecting a URI, so we want a new URI. And now we need to pass any URI to the image. Now, our image is here. By default, when you've got an image and it's a resource, again, another kind of quirk to WPF, something you'll just get used to, is to access, say, this folder, because you can't just pass back URI, and let's just prove we can't, in case things change. So images drive.png, oh, ping png. See if that works. No, see, so that's crashing, invalid URI. So you can't just go ahead and pass in, an image as if it's just there, because this is a resource, so it's embedded in the application, if you will. We need to specify, and again, this is a very hard-coded fixed thing, and you do it with pack, which is the package, :2// application, : comma, 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 and then your path, which starts with a /. So this bit here, even though it looks weird, is basically a way of accessing the way that WPF compiles the application, and it puts the resources into packages, and you want the application package. It's, again, something you don't really need to know. You just need to understand that if you want to access resources in WPF as URIs, this is the special string that you use, and then you just use the normal folder. So if we return this, we should access the images drive. And there we go, we're back to accessing the same icon. So now what we want to do is replace this only. So let's cut that out, put in, let's call it image, and now specify the image, and by default we want it to be, say if we don't know what it is, if all the other logics fail, we're going to presume it's a file. So we're going to do images.file png. By default we presume an image, and then now all we need to do is replace the nice looking string with what we expect, where in this project we want to replace the image with. So we want to detect if we've got a drive. So let's get the name as well, which will be useful. Which is we put that helper function in main window for now. Get file folder name paths. So this will get us just the name of the item. By default we get an image, and then we want to do some logic check now. So to find a drive, we know if we get the file folder name, no, we don't want the name, we want the or do we? The name's gonna be, yeah, the name is gonna, no, the name's gonna be blank. Let's try it anyway. In fact, let's just breakpoint here and let's see what we're working with. So at first, the path is C, the name is blank. Yes, this is the only tricky thing, is detecting the path. So I think if the only time file folder name to get the the name of a folder, the only time that's ever going to return blank like this is in the case of if it's a drive or a blank string, which will never pass in. So I think we're safe to assume if we get so let's comment this. So the only, in fact, yeah, we don't need to do anything there. So if the name is blank, we presume it's a drive, as we cannot have a blank file or folder name. So we're sort of process of elimination here, which is good enough for this example. So if string dot is null or empty, the name, then we're a drive. We want to set the image to images drive.png. So we've got a file by default, so we don't need to find a file. We're doing this to find the drive. So the only other thing left now is, if it's not a drive, to check if it's a folder. So in C# to check if like a full path is a folder. So this path here is a folder. You need to first create new file info, and then you need to pass in the string, and then there's dot, and I think it's attributes, what is it? Attributes.has flag, that's it. So we'll check if the attribute has is it file attributes.directory. There we go. So this basically checks if this path is a directory. So file info gets things like file size, last modified date. You can just press dot and have a look. Creation time, last modified date, if it exists, the full name, the file extension, all this information about the file. Usually what you see when you right click on a file and click properties. And then the attributes are, as you'll see here again, whether it's a file, a folder, an archive, read-only, system file, I think hidden as well is usually in here, yeah. So, a few attributes. One of those is whether it's a directory or not. So we're saying if this path and the attributes contains a directory, we know it's a folder. So if we get that, we want to show the folder closed PNG. So this now, if we press F5 and run this again, so the first three should be drives. So you got the path was C drive, the name comes out null, so we default to a file, but then we find out that the name's null, so we replace it with a drive. So the image becomes images drive, and then we're going to return the drive image. That'll happen for all three, which is good. Now the next one shouldn't be drives. So we've got the path of C recycle bin. So the get file folder name should return the recycle bin, which it does, so now it's not blank. So this ignores. So now we're going to check if C drive directory, C drive recycle bin is a directory, which it is. So we return closed, an image folder closed. So that's finding folders, and then everything else that it doesn't find, if it's not a directory, is going to end up being a file. So we run that, and you can see now we've got files, folders, and we've got files. which match the C drive. So if we go to C drive, you can see recycle bin's hidden as well. So you could go that further step and make this semi-transparent. You could do like a 50% opacity if it's a hidden folder. But if we just did like view hidden, we can see that. So, oh, in fact you can't even see that. We're actually finding things that the hidden isn't showing. So we should be able to access that though with typing in the exact name, recycle.bin, and there you go, we can access that folder. So we're actually finding folders that even, you know, the Explorer isn't showing, which is quite cool. There's quite a lot of them they're not showing. So there's your folders, and that's almost it really. That's the whole thing done. So now if we expand things, you can see you can browse and you can find files, and you know, that's the tree view in itself with icons for specific types. So you know, that's quite cool. So hopefully this was a nice introduction to TreeViews. It's complicated enough that we've done an image converter, which hopefully you understand fairly basically. We get given a full path, we find out whether it's we determine whether it's a file, a folder, or a drive, and then we return the images from these folders to set the source of this image here. We showed you how to create this first before it's in a list, and then the text of it is just centered and it binds to the header itself. So hopefully that's all come together quite nicely and it was easy enough to understand. We can go through this a lot more and we could add more, but like I say, the next thing we really need to do is to start doing view model binding, because if you look at your code now, and this is the code behind the view, so this is the XAML code, and we've got a lot of logic. Well, we've got all the logic here. We're getting folders when we expand a folder, so when physically we're clicking a UI element, we're then running some code, and then we're affecting other code, we're then actually adding to the actual folder view and the actual, you know, another UI element here. So this code and the logic, if you will, your data and your logic is very hardwired to your view. So now let's say we wanted to convert this application to a Windows Forms application or a web application. It's going to be, and imagine if this is also a lot more complicated and you've got, say, 10,000 lines of code in here. This is very hard coded to this view. You come to change this view and go to a Windows Forms application, you can't just move this code. You're going to have to cut and paste this. You're going to have to change the folder view to then access the Windows Forms UI. This event won't be the same. It won't have rooted events, so this whole functional change. So what you're going to end up doing is cutting and pasting and moving and repeating all your code. It becomes completely unmanageable. So the point of view models is to get away from this, putting your code, the purpose of your software and your application, instead of it being hard tied to a very specific UI, because this could be moved to multiple UIs. It could go to phones, it could go to, you know, an Android and iOS, could go to anything. The point of view models, in short, is to separate the code behind, so your actual physical code that does stuff, from the view. So obviously this code, when you're expanding your drives, needs to link to a UI, but instead of actually doing it here and physically linking to the UI and physically looking out for events and things, we make a view model, and that's still a C# class, but it's like the bridge between the view and this data. So it's like an intermediate. It's sort of an adapter, if you will, or like a connector, where we start bridging the gap between these pieces of information and then these type of attachments. So we'll go over that in the next video, and we'll take this exact code. Now you've seen how it's been done by hand, if you will, by just manual events and physically just finding things, and we'll convert this exact project into a view model project, so you can see the difference, and you'll also see then how much cleaner it becomes and how much easier the UI starts to look in terms of how it works. I mean, these bindings won't change much, but still it'll look a lot nicer than this. So hopefully that was a useful video, and you can, like I say, carry on and expand this. You could have it so, say, when you double click the file, it actually opens up in Explorer. So if you double click this, it runs. Or you could have so you can right click an item and open the folder, or you can do what you like. You can just think on this. You could even go to the extremes of adding another panel here, so this splits off into a grid with 1/3 and 2/3, and this side becomes this view, which could be another tree view, which could be shown differently. So when you click in here, it's showing the folders here, similar to to this. So you can feel free to expand on this and play, but that should be enough to get you some very basics into collection views and value converters. So I'll try to do this next video in the next day or so. I know everybody's very keen on the WPF, and we'll take this project and we'll clean it up and we'll do view models, and then we'll get started on the chat application, which is going to be a very long set of videos. It's going to go over months, no doubt, but you'll learn so much from it. So we're going to start working towards a real application. So I hope you enjoyed this.